Hello, hello, hello. We're moving on to our next stage now, which is the calculations for price elasticity. So let's get into it. As a quick reminder, elasticity represents the gradient of the line, the gradient of the demand line. If we are inelastic, it means that when we increase the price of a good or service, the percentage change in customers or the percentage change in goods sold does not reduce as much as the percentage change in price. However, if it's elastic like D3, if we increase the price of a good by a little, we lose a considerable amount of consumers. And generally, elasticity is based on substitutes. How many substitutes you have available will determine how picky you can be as a customer. So one thing that's really important to understand is elasticity along the line. Elasticity from this point to this point is going to be different from elasticity from this point to this point. So we need to calculate this using the equation and work it all out. We can see that this is the elastic zone and this is the inelastic zone of the line. So sometimes you get an exam question that basically it will ask you from the start of the line to the end of the line what the elasticity is, and that's relatively simple. It's just two numbers. Sometimes they'll ask you which part of the line is elastic and which part is inelastic, and we just need to quickly understand why. So basically, on this side of the line, as price goes down, we can see that our revenue is going up, meaning the increase in quantity demanded must be higher. Our revenue is going up. We've lowered our price, but we're still making more money. That means the customer response must be higher, okay? When we get to this middle point, we've lowered our price from here to here, but our revenue hasn't changed. This means we must have a unit elasticity where it's the value of 1. The change in price is very similar to the change in quantity demanded. Our revenue stays the same. The money we make stays the same. As we move down this, we continue to lower our price, but now the revenue we make starts to lower as well. And if we're losing revenue as we lower price, it means that it's inelastic because we might just have the same customers buying the same goods at lower and lower prices, and therefore our revenue goes down. So that's why it goes from elastic to unit elastic to inelastic. Okay, let's move forward. Now to demonstrate this, I'm going to show a line moving this way, okay? We're going to use the equation which is PED equals percent change in quantity demanded over percent change in price. We need to ingrain this in your brain. And basically, if we move from A to B, we can see on this graph based on the numbers, we're going to go from 12 to 10.2. So we've reduced our quantity by this amount in exchange for this increase in price, okay? 0 to 0.5. Now, any percentage increase in 0 is going to be what? To get to 0.5, it has to be an unlimited increase. And this percentage here has to be minus 15%. We've worked out here is basically the equation already. So we know the percentage change in quantity demanded is here. The percentage change in price is here. So our PED is 0. 15 over unlimited has to be 0. Meaning at the bottom, it's perfectly inelastic. And have a look. This correlates with this idea that we just looked at. Okay? So the idea is then, as we move up this line, we should become more elastic. And we can show this. So now, when we move from B to C, as shown here, our price has gone from 0.5 to 1, which is now actually a 100% increase in price. We've got some more logical and reasonable figures, right? But the quantity demanded now is minus 16.67%. And when we run this over that, we get this figure. So this is showing us that PED, as we're moving up the line, has increased from 0 to 0.1667. Make sense? So as we move up the line, our elasticity is increasing. And finally, when we go from C to D, we're getting an even bigger increase. It's still considered inelastic. We've still got further to go. But at this point, we can see elasticity increases again using the same idea. Okay? Now, moving forward. So looking at this, can you identify any products you're an inelastic buyer of? I know what I'm an inelastic buyer of. I like really high quality eggs with thick shells, orange yolks. Oh, sensational. absolutely an inelastic buyer of those. Moving forwards, we have to quickly look at how revenue works here. So basically revenue equals price times quantity. So if we look at price 1 here, we know this company, it's selling cigarettes at $1, and the amount they've sold is around 7.5 million. So the money they get in their bank account is 7.5 million times $1. That makes sense, right? Now, if they decide to increase the price of this inelastic good, they've increased it by 100%, which is a lot of money. Now it's $2. The reduction isn't that high. They're still selling 5.5. Can you see that? So now for the revenue, we make 5.5 million times 2, and that gets us 11 million. So what's happened is basically, if a company can manipulate inelastic goods, they can make massive profits by increasing the price, because they know the reduction in customers isn't going to be as great as the increase in price. I hope that makes sense. On the other hand, though, if you're a company that has elastic goods and services, you might need to do the opposite to make some money. Because what we can see here is, if you were selling at $1 this toothpaste, look how many customers you have. You're making 12 million from this transaction. $1 times 12 million. However, if you increase the price to $1.50, you've increased it by 50%, you've lost a much higher percentage of your customers, around 70-80%. So now we're only making 4.5 million from this transaction. So it makes it clear that if we have elastic demand as a company, it's definitely well within our rights to lower the price as much as we can in order to gain advantages from selling to lots and lots more customers. This is a further breakdown of our calculations, okay? Just quickly for cigarettes. So, some people were asking me about the calculation, so let's do it here. So we know that cigarettes, the difference in quantity demanded, it's gone from 7.8 to 5.5. That difference is 2.3. Now to calculate this percentage difference of moving from 7.8 to 5.5, we need to work out how much this is in minus. All we do is we take this difference, 2.3, put it over the original figure, okay, and times by 100. So we can see that we have lost 29% of our customer base. However, when it comes to price, we just do the same methodology. Difference is 1. Our increase is 1 over 1 times 100 using this new figure over the original. And the value is 100. Following this equation, percent change in quantity demanded over percent change in price, we can see our PED is 0.29 or minus 0.29, which means it's between 0 and 1, which is inelastic. And for toothpaste, what we just saw in the example, we do the same thing again. Look how many customers we lost. So many. Okay. We take this number over the original. Okay. And then for the percentage change in price, we know we've risen the price by 50%. Okay. So we're going to do this value over 50%. 75 over 50%. PED is minus 1.5. This value is above 1, meaning PED is elastic. Okay, so pause the video. Think about this. If PED is above 1, okay, so have a look at these, pause the video, have a think. So if PED is above 1, that is elastic in demand. It means the change in quantity demanded is greater than the change in the price changes. If PED is less than 1, if PED is less than 1, if PED is less than 1, then we're going to have inelastic demand, meaning the percentage change in quantity demanded is going to be lower than the change in price. Companies can manipulate this to make some money. And what if PED equals 1? Unit elastic. So a 10% change in price will lead to a 10% change in quantity demanded. Have a look at this. All right, moving forward. Practice problems for you. Pause the video and have a crack. The first one means you've got to calculate the percentages as well and work out if it's elastic or inelastic. So let's have a look. Did you manage to get this? So our percent change in quantity demanded is minus 10.71%. and our percentage change in price is 8%, leading to a minus value of 1.33. So this value is above 1. So this value is above -1, okay? This means it is elastic. The percentage change in consumer response is greater than the percentage change in price. So knowing that it's elastic, they should be able to manipulate this to make money. Maybe they can lower their price. Okay, Anna owns a sweet chocolate store. You know what the elasticity is? It's 2.5. Is that going to be elastic or inelastic? Have a think. Above 1, elastic, right? She wants to increase her revenue. So what would you advise her to do? Well, here's the definition first. So elasticity is 2.5. For every 1%, we're breaking this down. For every 1% the price increases, quantity demanded decreases by 2.5. So for every 1% the price decreases, the quantity demanded will increase by 2.5%. So my advice for Anna would be to lower the price, increase sales volume of her chocolate. But she's got to be careful. If she lowers it too much, she can't lower it beyond the cost of production. That will be pointless. So yeah, something to think about there. All right, I want you to pause this video and I want you to calculate all of the movements, A to B, B to C, C to D, D to E, and show me if you understand the calculations of PED without any help. Try and remember the equation. Percent change in quantity demanded over percent change in price. Off you go. Did you get these values? I hope so. Moving forward, here is an exam question on PED. So again, it's asking the most important thing, because economists want economics to be relevant. How can a company use this? How can it influence a firm's pricing decisions? So we need to split it into two sides, don't we? We need to look at the elastic side or the inelastic side. So if a firm knows their product is elastic, what can they do? It means the percentage change in quantity demanded is going to be greater than the percentage change in price. So they should lower their price. If they lower their price, they can increase their revenues and hopefully make lots of money. It's also, like I said before, if consumers are picky, if they're price elastic, there's probably a lot of substitutes. There's a lot of different goods they can buy similar to yours. So you've got to compete on price. And remember, the line looks like this. You see that elastic demand line there? That's what it looks like. A small reduction in price leads to a greater quantity demanded and a greater revenue. Next, what about the price inelastic organizations? What can they do? Look at this inelastic demand line. If they increase the price, look what happens to their revenue. The percentage change in quantity demanded is lower than the percentage change in price. So if you raise your prices by a substantial amount, you don't lose many customers. And that's where that delicious, tasty money comes in. And businesses can increase their revenue. And remember what I said about substitutes? Not many close ones, because if there was close substitutes, consumers would choose something else. Think about petrol in cars or cigarettes. Saying that, there is a new substitute for cigarettes, isn't there? Vapes. I wonder how this is going to affect the industry in the long run. So you get 6 marks if you're able to describe the level of substitutes and what would happen with the company if they raise or lower prices for each type. However, there is one other one you could have put into this in the real exam question. You could have also discussed unit elasticity, meaning that if the value is 1, if you raise or lower the prices, you still tend to get the same revenue. Well, this is what it says in the exam question. This is a real mark scheme for a real CIE exam question, okay? We know that revenue does change, but they're okay with saying that it doesn't. There is also a good criticism of the whole thing. It can be difficult to calculate. If I calculate PED today, it might be different tomorrow. If I calculate PED in Spain, it might be different to Switzerland. There's so many variables that go into who's there on what day and what prices you should do and how much you sell them for. It can be really difficult to have realistic ideas about what PED means for a company. It can be super expensive and a waste of time, if you don't believe in the theory, of course. So basically, the more data, the better. All right, that's it for me for GCSE level PED. If you're interested in any private lessons, you can book down below. Hope you have a good day, and I'll see you all again.